Hello everyone, welcome to today's video. We're going to be starting talking about data. So we're looking at populations, samples, and inferences, all relating to data sets, which we can represent lots of different ways. So when we're talking about data, most of data really is understanding key vocabulary terms. So there are 6 key vocabulary terms we're going to look at today. We're going to define them and then we'll look at some examples that apply them. So our first vocabulary word is population. Population means an entire group of objects from which data can be collected. So I'm sure you've heard population before. You've probably heard like the population in the United States is, right? That's like how many people are in the United States. So it's an entire group of objects, people, animals, plants, that we can get information from. So you could say the population of Philadelphia. That means every single person living in Philadelphia. So that's population. That's the biggest category. And then we have a sample, which means a subset of that population. So subset means like a smaller part of a larger group. So in this picture, we have the population, which is going to be all 12 people. So all the people in the world that we're talking about here, there's people 1 through 12. And then we would take a sample of that population. It means a smaller subset of that population. So now we don't have all 12, we just have 4 people from that population. Okay, so that's the idea of a sample. And then we can have representative samples and random samples, which are connected. A representative sample is a sample that has the same characteristics of the population, like about. So if we were to talk about a population that's every single person in the United States, if we then took a sample of those people and we only talked to people that were under 10 years old, that's not a good representation of the entire population of people in the United States. Old people, young people, middle-aged people, right? You need to represent everyone. And we can often get a representative sample by taking a random sample. So that's often done with computers. If you've heard of like a random number generator, technology can be defined more or less to come up with random numbers or randomly select people. So once something becomes random, with time that also becomes a representative sample. So once we have our sample, we would normally in an experiment or when we're trying to figure out information, we would get information from that sample and then we would look at that data and try to figure out a conclusion that we can make about the data. So this is something you all do all the time with our graphs of the week. So this is a big 7th grade skill and it's something we practice a ton. It's looking at data and being able to interpret that data and say what's going on, right? So you can make a conclusion on a graph of the week by looking at it, understanding it. Oh, I see that they're saying this, so you make a conclusion about it. And a valid inference versus just an inference is an inference that's likely to be true about the entire population. So again, for example, maybe we are trying to think about all people in the United States, but we only interview people under the age of 10. And we ask them, what's your favorite TV show? And then they give an answer that's a kid's TV show. It wouldn't be a valid inference to say that the favorite TV show of all people in the United States is that TV show, that kid's TV show. It might be a valid inference to say it's the most common favorite TV show of kids under 10, but not if we want to talk about the entire population. So you can make inferences that aren't necessarily valid, meaning they're true about the whole population. A lot of information. It'll become clear through examples, but you should be referring back to that vocabulary as I ask you questions and as we go through these. Okay, so for our first set of examples, we have a scenario. A gym wants to determine if its customers would prefer that money is spent on a new basketball court or on a new weight room. The gym has 500 members. It samples 50 members by having a computer randomly generate 50 of the 500 members for employees to ask which they would prefer, a gym, a new basketball court, or a weight room. Okay, so question number 1 is, what is the population in this situation? So the population in this situation is going to be all the people that belong to this gym, all the members of the gym. So take a look at the question again. And tell me how many people are members of this gym? Yeah, there are 500 members. The gym has 500 members. So there is a population in this situation of 500 members. It's the entire group of people from which data can be collected. So we are only talking about in this gym what would members prefer, so that's all 500 members. Alright, so that's going to be my answer here. Okay, the population is the 500 gym members, aka everyone who belongs to the gym. And then for question 2, what's the sample in this situation? So the sample is the subset of the population we would actually go and interview. So how many members are we actually going and interviewing in this situation? How many are we sampling? It samples 50 members by having a computer randomly generate 50 of those 500 members. So the sample is the 50 members who the employees ask the question of which they would prefer. So the entire population is the 500 people who belong to the gym. The sample is the 50 members we're actually going to interview. It's a subset of our population. So question number 3 says, is this sample likely a representative one? Explain. Okay, so we want to ask ourselves, what's a representative sample? Okay, let's go back to the vocabulary. A representative sample is a sample that has the same characteristics of the population. Taking a random sample is one reliable way to produce a representative sample. Okay, so we selected 50 members. They're not telling us too much about those 50 members, but it did tell us something important, that a computer randomly generated 50 members out of the 500. Okay, so if it's computer generated and random, that means we definitely have a random sample. And a random sample is one reliable way to produce a representative sample. So yeah, this is going to be a representative sample most likely. So yes, this sample is likely representative because it is a random sample. Alright, that's all you need to say. Alright, and then our last question for this situation is question number 4. What would be an example of a non-representative sample in this scenario? So in this case, we know they randomly chose 50 members. But what would be an example of a non-representative sample, meaning a sample that likely doesn't have the same characteristics of the population? Well, we're trying to figure out if customers would prefer a new basketball court or a new weight room. So if the gym, in order to figure out what they would prefer, just hung out in the basketball court and only asked people in the basketball court, do you think we should get a new basketball court or a new weight room? Probably those people are going to say a new basketball court because they care about basketball. They're playing basketball all the time. And then if they went only to the weight room and they only asked people in the weight room, the people in the weight room are probably going to say a new weight room because that's what they really care about. So those would both be non-representative samples. If you only ask people whose situations, interests made them clearly have some strong bias. They clearly preferred the basketball court or they clearly preferred the weight room. Alright, so it's just asking for one. So I'll go with the one I started with. A sample of 50 people who they find playing basketball in a day. If they only ask people who are playing basketball, that's probably going to not represent the entire population because probably not everyone at the gym goes to play basketball. Probably some people go to lift weights, others run the treadmill, right? So people are going to have different opinions. But if you select people randomly, it's likely you're going to get a good sense of everyone. Okay, so that's how we would ask these questions. Now let's look at the data that we get from them. Alright, so we have our next example, which is related. It's going to feel a little bit more like math, but all of this is math. So it's a gym wants to determine if its customers would prefer that money is spent on a new basketball court or a new weight room. Same situation. Of the 50 members who were randomly sampled, 32 say that they would rather the gym spends money on a new weight room. Use this data to estimate the number of 500 members who prefer a new weight room. So to do this, we can set up a proportion. Okay, which is again when we set equivalent ratios equal to each other, and then we can solve it to find a missing variable or missing information. So we know that 32 out of the 50 members sampled said that they preferred the weight room. Okay, so that's my part is 32, and it's getting divided by my whole, the total number of people that were interviewed. And then I'm going to need to set this equal to another ratio. That's again my part to my whole. So if I have 500 members total, that's going to represent my whole. I have 500 people, and I need to figure out x. Okay, the number of people then that we expect of all 500 members who would prefer a new weight room. So it's probably not going to be exactly accurate, but our random sample can make us have a good prediction. So now we just need to solve this proportion. Okay, there's lots of ways we can solve it. We can solve it as really seeing it as an equation. We can ask ourselves what's currently happening to my variable, and then how do I undo it? So if I find my variable x, x is currently being divided by 500. So how do I undo dividing by 500? Multiply by 500. Great. So I can multiply by 500, multiply by 500. Okay, it would look like that. The 500s would cancel. You would just get x. And then when you do 500 times 32 divided by 50, it's going to give you the final answer, which was 320. Okay, personally, I wouldn't really go about solving this proportion that way, though, even though it is a great method. It will always work. This situation, I can use my mental math skills a little more. So we did this before. You can find an earlier video on it. But I can ask myself, okay, from 50 to 500, what am I multiplying by? Is there a number I'm multiplying by? Yeah, I'm multiplying by 10 because I'm just adding a 0. So that means I'm multiplying by 10. So then if I want to figure out the equivalent numerator for an equivalent fraction like I have here, I would also need to multiply by 10, which again just means you're adding that 0. So 32 50ths is equal to 325 hundredths, meaning that we would estimate that there's 320 members who would prefer that new weight room. So again, I just set up a proportion and then solve that proportion. So we're going to look quickly at inference. Okay, so like I mentioned, inferences is what you do with the graph of the week every week. So I'm not going to spend a ton of time focusing on it, but here's a really quick example. So Aaron conducted a survey of the type of shoes worn by a random sample in his school. The results of this survey are shown at the right. Make a valid inference that compares the number of students who are likely to wear gym shoes and those that are likely to wear boots. Okay, if I'm looking here, gym shoes, I have 19 people. Boots, I have 6. We're told this is a random sample. That means it's representative. So a valid inference would be it's likely that in the school, more students are wearing gym shoes than they're wearing boots. That's all it is. Because in our sample, more were wearing gym shoes and boots. So then I could make a valid inference to say in the entire school, the entire population, that's probably true as well. Okay, and then one quick example of a not valid inference would be this example. You got to watch out for ads like this. 3 of the 5 medical doctors surveyed by a biochemist prefer his newly approved brand X as compared to the leading medicine. The biochemist used these results to write the TV advertisement shown. Is this inference valid? 3 out of 5 doctors prefer brand X medicine. So this is misleading, but this is not a valid inference because the biochemist only asked 5 people. Think about how many medical doctors there are in the world. You can't just ask 5 doctors, get an answer from 3 of them, and then say that means for all doctors in the world, 3 out of 5 doctors prefer brand X. No, it's just of those specific 5 ones, only 3 of them did. We have no idea if he randomly sampled to get these 5 doctors, but probably not. And even if we did, in a situation where there's only 5 people asked, that's not really, you can't really make that claim. So it's unlikely that this inference is valid. It's unlikely that it actually represents the entire population of medical doctors. And of course, this is something that people will do because people want to make money. Okay, great job, everyone.